Oogenesis, that is the production of eggs, or also called oocytes. They're actually not ovum or eggs until they are fully mature. Ovum. So in the last video, I told you there are about 200 to 500 million sperm per ejaculate. That's insane. So sperm are produced all the time from stem cells, spermatogonia, and produced all throughout life in the male. Females, oogenesis, the timing of it is very different. So by birth, there are 1 to 2 million oocytes. They are secondary oocytes, is the stage they're in at that point. And up until like puberty, about only 25% of those remain. So there's about 300,000 from puberty when they start being released and maturing and on. And then not all of them, most of them don't ever become ovum, mature ovum. It's actually not until it's fertilized that it completes the developmental process of becoming a egg. So the quantity and timing is very different. Fewer eggs are produced and it's a limited supply. I mean, it's plenty, right? Like who wants to have 300,000 kids? I hope no one. I think 2 is enough. Sometimes it seems like more than enough. Okay, so oogenesis, we are going to, the other big thing is that oogenesis is complicated by follicular development. An ovum is literally just, we're gonna just start with this now. It's gonna start with 2N, what's that? That's a diploid organism, right? These are going to be the stem cells that are called, I hope I spell this right, oogonia. One is an oogonium. These are like spermatogonia, but this is a female cell. And they're stem cells, just like spermatogonia are. These are going to be embedded in a follicle, and the follicle is going to have its own developmental cycle. And that's what you think of when you think of, well, the ovarian cycle. It's mostly the follicle that is changing, and that's that follicle stimulated hormone is going to do that. So how I want to do this is I'm going to teach you about oogenesis first, then follicular genesis, the development of the follicle. When I teach you the follicular development, I'm going to tie back into this. This is going to be a lot like spermatogenesis, but then itself, but then there's going to be some differences. And then pulling that in with the follicle development is going to be the harder part. So that's going to be the next video is where we'll put those together. So in this video, just want to do oogenesis. No follicles in the picture. I mean, they really are in reality, but we're not going to look at them yet. We're just looking at the egg itself. So in utero, these stem cells divide. And I just told you that by birth, there's already like, they're done dividing. So this is all going to happen in utero, right? In a developing fetus. Just like with the spermatogonia, we're going to have cell division, mitosis. This is what stem cells do to reproduce. There's going to be one going this way, and one is going to go back and stay a oogonium. So this one is the one that's going to carry on. And that's just like spermatogenesis, where we had that stem cell population maintaining itself and reproducing. This, however, is going to stop at birth. So we've got birth, that process is stopping. We then have development, though, into I'm sorry. So this one is going to, when it divides like that, just like the I think I messed this up with the spermatogenesis as well. The one that's going to go on is going to become the, and I'm just going to put it like on. This is the same one. It's going to become the primary oocyte. So oogonia develop. They're going to divide, and they're going to develop into primary oocytes when they divide. This is actually then going to carry on until puberty. At puberty, all of your eggs, they're actually oocytes, we call them eggs, are primary oocytes. So everything just hangs out. Some of them actually degrade at that time. At puberty, that's when these are going to go through meiosis 1. And I'm going to do actually different colors for these. I'm going to keep it consistent, so I'm just going to circle them. Circle my meiosis 1. What does that mean? That means the cell is going to divide and become haploid. This is the same thing that happened with the sperm. The difference is that this cell division is a little bit different, and it's going to make one that's smaller, like physically smaller, and one that's physically bigger. This thing here is going to degrade and be recycled. This is our polar body, our first polar body. It's a cell, but it's like not equivalent. It's not the primary one. Only one is going to carry on, unlike the sperm, where they both eventually were going to become sperm. In this case, this one is the one we're following. This one is the one that's going to become an egg. This is our secondary oocyte. So the secondary oocyte is haploid, and it is the stage at which your eggs are, like, just in general, like until they get fertilized. So from puberty until on. It's actually not until fertilization that this next division is going to happen. So I mean, add a different color here. Let's do a big old orange for fertilization. That means that the sperm has entered the egg and combined DNA, and that's going to allow this cell to complete meiosis 2. And thereby form an ovum, which then immediately gets fertilized, right? It is fertilized. I know it's kind of weird. This is our second polar body. So of all of this process, only one ovum develops, unlike 4 sperm, right? I'm going to circle my meiosis 2. So this process, the complete ovum, does not occur until fertilization, and then immediately it becomes diploid again because the 2 cells are combining. Pretty cool, right? Okay, so we're going to leave it at that. That's the production of the egg. The next video, we're going to look at the follicular development and how this ties in with that.